Yeah, hi guys. Just please confirm if I am audible and visible clearly. Great. I hope YouTube maybe everyone can hear me. Yes, people are saying that they can. So this stream, this today's class that we are having on basic mathematics is streamed simultaneously on Unacademy as well as YouTube. I'll try to have a look, at both of the comment sections and chat of both of the platforms. But my more of my focus will be on Unacademy. I'm sorry about that. So if you want to be part of the discussions in a better way, I just suggest you to come to Unacademy. But otherwise, it's okay if you want. You are at Unacademy. You are at YouTube also. All right. So am I not audible? Like some people are saying that I am not audible. I hope I am audible. All right. So if I'm not audible to some people, please try and refreshing the page. Maybe there is any technical issue which will go away after we refresh, the typical Indian method. All right. So before we begin, let me just introduce myself in a very brief manner. My name is Pulkit Chhabra. I am a fourth year undergraduate student at Delhi Technological University. So out of all the educators that are here today, except me and Nishchay, all of the others are working in companies like Google, Facebook, Flipkart, LinkedIn, etc. Just me and Nishchay are the ones who are hosted in college. Anyway, I've interned with Coordination and HackerRank in the past. For those who from India may have heard of Coordination, but uh, okay. So someone is saying that there is something wrong with my network. Let me just check it. I think my network is fine. I don't think that something is wrong with my network. Please try and refresh. I just checked the speed and it's close to 45 Mbps. It's fine. All right. So I was saying that hi Pari. So what I was saying is that I've interned with Coordination and HackerRank in the past, and if I talk about my competitive programming profiles, because that's the reason that we are here. So I am a 6-star at CodeChef and a master at CodeForces, and I go by the name coder underscore Pulkit underscore C. So yeah, I think enough about myself. Will Before beginning, I'll just let you what I have planned for this class. And if you is there, I realized that some problem was there in the previous class as well. Honestly speaking, there is no issue from my side. Maybe the only solution I can think of to recommend you is refreshing the page if you are experiencing echo in voice. All right. So yeah, I'm sharing the agenda. So uh, for this class, what we will be discussing is we will start with calculating. We will start with the power function. Let's say if you are given two integers a and n, and if you want to calculate a raised to power n, how can it be done in an efficient manner? And then we would. Okay. Just let me ask you guys. What language would you guys prefer for the purpose of this class? What language would you prefer? I'll go with the majority. So I'll not in that manner. I'll be using C++ only. I don't know. I'm talking about the language in which I speak in. So English, Hindi. I'm sure nobody is going to select the option 4, but I can speak in Punjabi as well. Anyway, something to think about. So just answer me what your preference is, and I'll listen to the majority. All right. So 38% people are saying in English and 48 are saying in English. So just let me know that is there anyone who is not okay with English? I know that the session was scheduled in Hindi because I myself am more comfortable with Hindi. But since there are some people who prefer English, I'll just go with English. If you are not okay with okay with English? True, false. If most of the people are okay with English, I'll just continue with English. All right, so 80 people are saying that it is okay, they're okay with English. So I just try to sort of speak in English only. If there is something which I'm unable to explain in an effective manner in English, maybe I'll just use Hindi in between sometimes. But yeah, mostly in English. Let's make it mostly in English. All right, great. So like I was saying, we will discuss with fast exponentiation, and then I would introduce you guys to what modular arithmetic is. Or for those who already know what the term is, well and good. If you don't know, you'll come to know it in this class. So then modular exponentiation, then we'll discuss a couple of simple questions. Then we'll look at Euclidean algorithm to calculate highest common factor of two numbers. By highest common factor, I mean GCD or HCF, whatever you want to call it. All right, so after that, if time permits, like we have 1 hour and I'm having another class after this as well. So if time permits, I'll discuss a couple of problems related to GCD as well. Otherwise, I'll just give them to you to practice yourself. All right, great. So far so good. Shall I continue with the agenda for today? Please give me a thumbs up if everything is fine, and I'm confused if voice is echoing or there is anything wrong. So I think most of the people are okay with are okay with the situation here. So I think we can continue. All right, great. So let's start. The first simple question that I have to ask you guys is, let's say you are being given two integers a and n. All right. Let me just write it in a more effective manner. So two positive integers a and n are given. Okay, so just calculate a raised to power n. All right, so in other terms, power of a comma n. So we want to implement this function, as simple as that. So what would be a very simple approach to do this? Like a very simple approach to do this would be just multiply a n times. Yeah, a very simple approach would be to just use the inbuilt power function that is there in C++, right? That is the simplest approach. But let's say you are being asked this question in an interview, or you need to know the working and you need to understand the working of this question on your own. So if you want to implement it yourself, a simple way would be, let's initialize our answer with 1. All right, and then iterate n times I belonging to 1 to n, right? Answer equals to answer into a, as simple as that, right? So this is the simplest method to do that, right? I don't think there is any simpler method or any more worse method to do this, So time complexity of this method would be O of n. The time that this method would take is O of n. So if you notice here, if you notice in this method, what is it that we are doing? After first iteration, our answer will be equal to a. After second iteration, our answer will be equal to a square. After third iteration, a raised to power 3, and so on and so forth. And after nth iteration, our answer will become equal to a raised to power n. So I hope so far everything is clear. I think nothing to explain. Yeah, great. So I'm getting a lot of thumbs up, so which means everyone is fine with it. Great. So if you notice, the underlying concept that we are using here without even knowing is that if I just point it out to you guys, the concept that is being used here is that a raised to power n is equals to a raised to power n minus 1 into a. right? That's what we were doing, right? We initialized the answer with 1, then we kept on multiplying it with a, right? After first iteration we had a, and after second iteration we just multiplied this a with a square. For third iteration we just multiplied this a square with a, so we got a cube, and so on and so forth. So this is the sort of relation that we are using, the underlying relation that we are using to calculate a raised to power n. I'll just keep on asking you again and again if it is clear. Just keep giving me a thumbs up so that I am sure that we are on the same page. Great, cool. So this is why, like we discussed, the time complexity of this is going to be order of n. Great. So there is another method that we can do, that we can sort of think of to make it a lot better. Okay, so what we are doing is, let's say we want to calculate a raised to power 16. All right, so to do that, what we were doing is, Ankit, don't worry, I'm explaining it again. To calculate a raised to power 16, what we were doing is, we first calculated a raised to power 15 and then multiplied with it by a, and then for a raised to power 15 we had a raised to power 14 and we multiplied it by a. So a raised to power 16 was like this, a raised to power 15 was like this, and so on and so forth, 16 times, right? So a very better method to sort of calculate a raised to power 16 could be, it is also equal to a raised to power 8 into a raised to power 8, if you see, and a raised to power 8 is equal to a raised to power 4 into a raised to power 4, and a raised to power 4 is equal to a raised to power 2 into a raised to power 2, and a raised to power 2 is equal to a into a, right? So in this method, in the method that we discussed, the O of n method, we were taking 16 iterations in a way, right? But in this case, if you notice, we just took 1, 2, 3, 4 steps. So log of n to the base 2 steps. Let me just write it in a more so this is O of log n to the base 2. Why log n to the base 2? Why is it the case? But like I am talking about a general case, I'll just also explain an exceptional, and then I'll also explain the case when n is odd. Like I said, in this case n is even. If 16, because 16 is even, we can write it as a raised to power n by 2. We can write a raised to power 16 as a raised to power 16 by 2 into a raised to power 16 by 2. Yes, Satya Pragyan, I'm explaining how is it log n to the base 2. So if you notice, at each step, like in the first step, the value of n has been divided by 2, and then in the second step the value of n has been divided by 2 again, and in the third step again divided by 2, in the fourth step again divided by 2. So what will be the time complexity? The number of steps it is required to make n equal to 1 by dividing it by 2, right? Yeah, I'm explaining the log part. So let's say we wanted to calculate a raised to power n. In the next step, we will be saying, okay, hey, to calculate a raised to power n, I need a raised to power n by 2. Then for calculating a raised to power n by 2, I'll need a raised to power n by 4. So for calculating a raised to power n by 4, I would need a raised to power n by 8. So after some k steps, it would reach to a raised to power 1, and a raised to power 1 is already known to us, right? So what I want is the value of this k. So the value of this k is what I am saying is log n to the base 2, because this is the definition of log. If you see, I divided it by 2, then by 4, then by 8, and so on and so forth. So n by 2 raised to power k, like in the first step it has been divided by 2, and in the second step, if you see, then by 4, in the third step by 8, and so on and so forth. So after k steps, n would have become equal to n by 2 raised to power k. Yes, this is only true for this is but I'll just get to the case when n is not a power of 2. Just give me a moment. All right, so if you notice, if n has become n raised to n by 2 raised to power k, so after k steps, let's say n by 2 raised to power k has become equal to 1. So this means that k equals to log n to the base 2. That's what it is, right? Because let me just write it again. So n by 2 raised to power k is approximately equal to 1. So it means that n is approximately equal to 2 raised to power k. It means that k is approximately equal to log n to the base 2. So that's what I am saying. All right, so now let's just define this in a more general manner, right? Let's just define it in a more general manner so that you can understand it more properly. All right, so let's say we want to calculate power of a comma n. All right, so what I am saying is, if n is even, power of a comma n equals to power of a comma n by 2 raised to power 2, right? Else, if n is odd, what I can say is power of a comma n equals to power of a comma n by 2's floor value for floor values square into a, right? So I hope you understand this now. Is it fine? Like, for example, okay, so if you guys don't know floor value, I'll just explain. So floor of 9 by 2 is equal to 4. So floor value basically means that that when we were in +1 and +2 studying for JEE, you must have heard of greatest integer function. So by floor I mean greatest integer function. All right, great. All right, so I'll just explain it in a more I just explained. So 9 by 2 basically means 4.5. 9.4 basically means 9 by 2 basically means 4.5. So I want floor of 4.5. So 4.5, what I'll do is I'll just consider the integer part of this and disregard any part that is after decimal. So 4.5's floor is 4. All right, so all I am saying is that, let's, for example, if I take n as even, a raised to power 10, we can say that a raised to power 10 is equals to a raised to power 5 square, a raised to power 5 into a raised to power 5. So but when n is odd, let's say I'm talking about a raised to power 3, sorry, a raised to power 9. So in that case, I know that a 9 by 2's floor value is 4. So a raised to power 9 is equals to a raised to power 4 square into a, because if I square the floor value, one more a will be required, right? I hope you understand this now. Is it clear? Please give me a thumbs up or confused. All right, so I can see that okay, so some people are still saying that it is not clear. It's okay, I'll just explain it again. No problem. All right, so what we will do is just let me know that do you guys know about recursion? In a poll, if you know about recursion, mark true. If you know about recursion, mark true. Alright, so most of the people know about recursion. More than 80% of the people know about recursion. Okay, so let's just try and code this out, and then I'll ask you if it is not clear. Then we will try and understand it in a more efficient manner. All right, let me just share my screen. I'll just implement the code. All right, and then we'll come back if things are still not clear. Let me just share my screen. Open the Sublime. All right. Just a second. I'm opening an Academy app on my phone so that I can see your comments simultaneously. Okay, so let's say we have this function calc power, which gets int a and int n, to in the input. So I what I want is I want power of I want a raised to power n in this case, right? So like I said, if n is odd, so to check if n is odd or not, so to check if n is odd or not, we do this. If n%2 equals 0, n%2 basically gives us that what is the remainder of n when divided by 2. If n%2 is 0, okay, so people are saying that they can't see me clearly, that they can't see the screen clearly. Let me just I've just zoomed in a little bit, maybe it would be clear now. All right, so if n%2 is 0, it means that n is even. If n is even, so half answer I can say calc power a comma n by 2, and then my answer will be equals to half answer into half answer. Else it means that n is odd. In this case n is even, and here n is odd. All right, here I would say int half answer equals to again calc power of a comma n by 2. So those who are thinking that this n by 2, I want the floor of n by 2, writing it like this in C++ will give me floor only. Writing it like this, n by 2 will give me floor only. All right, so like I said, I know that my answer is half answer into half answer into a. Great. But now if I run this code, it will get into an infinite loop. Why? Because let's say I want to calculate a raised to power 2. So now it will say that calculate, people are guessing it correctly. So those who have a bit of an idea about recursion, we also need a base case to tell it when do we have to exit from the recursion. So here we need to add a base case, which is that if n is equal to 0, we can simply return 1. I hope this is clear, because if n is 0, we are looking for a raised to power 0. If we are looking for a raised to power 0, it means that a raised to power 0 equals to 1. As simple as that. So now this code is complete. Now I'll just give you an example. Let's say cout calc power 2 comma 4. Let's start with a simple one, which is right 16. Let's say we have 3 raised to power, let's say we have 5 raised to power 5. 3125, I'm hoping it would be right. Let's 10 raised to power 5, so it would give us 1,100,000, yeah, which is right. Great. So this is how it is working. Now let's try and dry run the code, and now with code I'll try to explain you how is it working and what is the time complexity. Great. So if you notice, I wanted to calculate a raised to power n. Okay, so for calculating a raised to power n, I said give me a raised to power n by 2 first, right? I said give me a raised to power n by 2 first. With a raised to power n by 2, I can calculate a raised to power n. And for calculating a raised to power n by 2, it would say give me a raised to power n by 4 first, because once we have a raised to power n by 4, then we can calculate this value, then in turn we can calculate this value, right? So this would go on until and unless n's value becomes equal to 0. So what will be the time complexity of the code? The time complexity of the code will be equal to the number of different values which are for which the answer is required to be calculated. So for how many values is the answer required to be calculated? N by 2, n by 4, right? The floor values of these, n by 8, and so on and so forth up to 0. So if you notice, the number of values that I have written here will be equal to log n to the base 2. I hope this is clear, because we are dividing by 2 and then by 4 and then by 8, we are going on until we reach 0. So this is a definition of log n to the base 2. So log n to the base 2 plus minus 2 there can be, but the number of values will be proportional to log n to the base 2. That's what I'm saying. Don't look at it a very exact manner. There can be one or two extra or less than log n to the base 2 values. All right. So yeah. So this is how we would calculate power of a comma n. And now please let me know. I'm hoping that a lot more people would have understood the concept clearly now. All right, that's great. Cool. All right, so this concept is called fast exponentiation. Cool. So what we have done here is called fast exponentiation. As simple as that. Exponentiation. Great. So and now what I'll tell you is now the C++ is having different variables, right? So like I use the variable name int, like I use the variable type as int, right? So integer can store numbers from approximately from 2 into 10 raised to power minus 2 into 10 raised to power 9 to 2 into 10 raised to power 9, approximately these many numbers. All right. It is actually 2 raised to power 31 anyway, but it is approximately in this range. So if you see, let's say I want to calculate power of let's say 25 comma 10, it would definitely exceed this number, right? So now what happens is sometimes we have these questions wherein we have to calculate different values. Yes, Naman, we can use long int. Long int can store numbers up to 10 raised to power 18. But again, let's say for example, I give you that you are given. Let's say I give you this question. You are given a set of n numbers, n objects, okay? A set of n objects where n can be up to 10 raised to power 5. N can be up to 10 raised to power 5. What you have to tell me is number of subsets. So we all know that the number of subsets will be equal to 2 raised to power n, right? So if the number of subsets are going to be 2 raised to power n, so what we are looking at is 2 raised to power 10 raised to power 5, right? So yeah, to answer some people's questions, what is the runtime complexity of POW function in C++? It is they use fast exponentiation only, and time complexity is log n only. All right. Great. So what I am trying to say here is that the value exceeds 10 raised to power 18 as well, and it is very large. So it becomes very difficult to check if the person's program is printing the correct answer or not. Puneet, don't worry, I'll just do that. But do what you are saying. Using long also I'll do. All right. So what has been introduced in this case is something called modulo modulo operator. So I'm sorry for the bad handwriting. I'll just try and write it again. All right. So what happens here is that uh, what happens is that a like I said, because the number itself is very large, right? So instead of checking the original number, that if the expected output is equal to the output that the code is producing, what problem setters do is tell the participant to print the answer modulo a given number. Generally the number that is used is 10 raised to power 9 plus 7. So modulo operator, I'll just explain you. A% B is basically remainder when A is divided by B. Cool. So since checking the original number is going to be a lot harder, so they just tell that, okay, hey, if your answer is 10 raised to power if your answer is something very large, just print the remainder that it will get when the number is divided by 10 raised to power 9 plus 7. So if you notice, let's say if our answer does not match the expected answer, it is possible that the modulo operator, after modulo operator, the remainder may match, right? But even if it matches, the only special thing is that like, not only special thing, some things I can explain, but it would require you to have a lot more knowledge about something. I'll try to explain it to you in a later stage. But one special property that it has is that 10 raised to power 9 plus 7 is prime. So there are some theorems and properties which are only valid for prime numbers. This is why 10 raised to power 9 plus 7 is used. And yeah, there are a couple of more things. I'll just explain them to you if I get a chance in the future. All right. So like I said, there is a 1 in a 10 raised to power 9, like, so 1 in a so basically 1 in a billion chance for remainders to match, right? So it is a good enough probability, so that is why it is okay, right? So I hope you understand what I'm saying. There's 1 in a billion chance that if two numbers are different and their modulo 10 raised to power 9 plus 7 matches, so we are okay to have this low probability, because the probability is low, so it's okay. It can happen sometimes that the answer was not actually correct, but we thought that it is correct. All right, anyway, so this is why this is where modular arithmetic comes into picture, right? Modular arithmetic comes into picture. So since we cannot store very large numbers, so it is not possible for us to calculate the answer first and then take modulo, then take remainder, right? It is not possible for us to do that. So we need to come up with modular arithmetic, so that our number is always sort of in the range of integer or in the range of long. All right. So like we discussed in this for loop case, if you notice, let's say if our n was equal to 10 raised to power 5, this answer would exceed the limit of int or long very soon. So we need to come up with a method that this answer always stores sort of answer modulo 10 raised to power 9 plus 7. So this is where modulo operations come in. So like I said, a% b is equal to the remainder when a is divided by b. So percent operator is already present there in C++. So a% b will give us the remainder when a is divided by b, given that a and b are positive. right? So now we need to sort of think how the modulo properties will behave when we are adding two numbers, when we are subtracting two numbers, or when we are multiplying two numbers, or when we are dividing two numbers, and so on and so forth. So I'm just writing down what the things are going to look like. So a plus b mod m is equal to a mod m plus b mod m plus mod m. All right, so this is one of the properties that I am telling you. Let's just prove it, which is it is simple to prove it. And so let's say a is equals to m into q1 plus r1. So q1 and r1 are basically quotients and remainders. I hope you get this. Let's say b equals to m into q2 plus r2, right? So in the left hand side, in the right hand side, sorry, in the right hand side, what do we have? We basically have r1 plus r2 percent m, and in the left hand side, if you see, what we have is m into q1 plus m into q2 plus r1 plus r2 percent m, right? If you notice, this m into q1 plus m into q2 is already divisible by m, because this is m into q1 and this is m into q2. This term will be divisible by m, so this term is not going to impact the remainder, the resultant remainder that we get. So it is equivalent to r1 plus r2 percent m. All right, so some people are telling me to repeat it. Why is m constant? M is not a constant. M is any general variable that I am taking. I'm just trying to calculate, I'm just trying to give you this property that if you are given a value and you are given b value and you want to calculate a plus b modulo m, what you can do is a modulo m plus b modulo m, then whole modulo m. All right, so the reason we are using modulo outside as well is, if you notice, मान लो इसका remainder r1 है and the remainder of b is r2. If the in general case the remainder should be r1 plus r2, but it is possible, like it is possible that r1 plus r2 exceeds m. So if it exceeds m, then we have to again take modulo. I hope you get an idea. Please give me a thumbs up if it is clear, or most of the people have not understood a thing. All right, I can see a lot of thumbs up, which means that it is clear. Great. All right, there's a mix. Some people did not understand. Okay, so guys, just have this. Just look at this example. Let's say m equals to 5, a equals to 12, and b equals to, let's say, 14. So I just need to calculate 26 modulo 5. What is the answer? 1, right? So what I am saying is, there is a property which you can use to calculate this value. What you can do is calculate 12 modulo 5 plus then add 14 modulo 5 and then take again modulo. So let's see what does this give. It will give us 2, it will give us 4. So I am getting 2 plus 4 modulo 5, and then if we see 2 plus 4 modulo 5 is equal to 6 modulo 5, which is equal to 1 again. So that's what I was just trying to explain. I was just trying to prove that this property is correct by taking an example that, let's say, m a is equal to m into q1 plus r1, where q is the remainder, q1 is the quotient when a is divided by m, and r1 is the remainder, and when a is divided by m, and so on and so forth. So I just told that this part of a plus b will be divisible by m, so this will not change the remainder, so which we can just replace it by 0. That's what I was saying, that LHS is equal to RHS, as simple as that. All right, great, cool. So the second property is a minus b modulo m is equal to, Yeah, the use of this property, I'll just after explaining you the properties, I'll just discuss discuss one or two questions. Okay, so a minus b is modulo m. If you notice, let me just ask you a couple of questions. Can anyone write on the chat? Like, it is a very simple question. Just writing it anyhow. Let's say, let me ask you, what is 6 modulo 4? Great, very easy. What is minus 6 modulo 4? Minus 6, sorry, minus 7 modulo 4. Minus 7 modulo 4. It is 1. It is 1 because the floor value of minus 7 by 4 into 4 will be equal to minus 8, and then minus 7 minus 8 will be equal to 1. So the remainder is 1. But what I am trying to tell you here is that in C++, the modulo operator behaves in a weird manner. So it's okay, don't worry. Let me just share my screen and explain to you what I'm trying to say. All right, so let's say, let me just copy the code that we had there, get rid of this function. So what I'm asking you is, if I do this 6% 4, I am looking at remainder when 6 is divided by 4. So remainder when 6 is divided by 4 is 2, which is correct, right? What I'm asking you is that what is the remainder, as simple as that, what is the remainder when minus 6 is divided by 4? This is the question that I'm asking. Durga, screen is visible. Please try and refresh. I have opened the Unacademy app on my phone and it is visible. Right, the answer is 2, as simple as that. So, but the answer is 2. But what I am trying to tell you guys here is that in C++, in the language that I am using here, it behaves differently. It behaves weirdly when we go with negative numbers. If I print this, it won't say 2. It would say minus 2. It would say minus 2. All right. So when I am doing coding, when I'm coding any approach which requires to use this property, what we will be doing is, I will be doing a%m minus b%m plus m modulo m. That's what I'm trying to say. Because if you try to prove this using the same method that we proved, a plus b modulo m, this plus m is not required. But if a modulo m is less than b modulo m, right, then the resultant would become negative. And like I'm not sure, Satya Pragyan, I'm sorry about that. I'm not sure about this, about Java. All right. So let me give you an example. So let's say a equals to 8, b equals to let's say 2. Let's say b equals to 3. All right, and m equals to 4. Cool. So if I calculate this, what will I be having? a%m is equal to 2 minus 3 plus 4% 4, right? So which is just a second. Okay, sorry, this is not 2, this is 0. I'm sorry about this. This is 0. Yeah. 0 minus 3 plus 4% 4, which is equal to 1. Right? uh, but if I do not do this plus 4, if I do not do this plus 4, then what I'll be having? Minus 3 modulo 4, right? And I showed you now, that that C++ is behaving weirdly if we take modulo with any negative number. So that is why I have just added one one time the m value, because adding an m value is not going to change the remainder, right? So that is why I just added m value, so so that we get the right answer. Please tell me now if it is clear. Why have I added this m value? All right, so I can't. There are some non-clears as well, but most of them are clear. All right, I think I'll have to move on now. I'm sorry if some people if it is not clear to a couple of people, but most of them it's clear. I'm sorry about that. All right, so the third one is a into b percent m. So again, very similarly, you can just open it out, and you can just you'll be able to see that this can be calculated in this manner: a percent m into b percent m percent m. All right, great. So this is what we can use. This is what we can do to have calculating to calculate the values under modulo. So now let's just go back here, right? So we called it fast expo, right? We'll have another function. I'll just copy down this function, and this function will be called modular expo. And like I said, I have this value 1 2 3 4 5 6 7 8 9, which is 10 raised to power 9 plus 7. 1 2 3 4 5 6 7 8, which is fine. So now what I'm trying to tell you here is that that why are we doing this a percent m and b percent m? Like I said, the long is less than or equal to 10 raised to power 18, and this m is less than or equal to 10 raised to power 9. So now let's say this a and b value are equal to 10 raised to power n. So if I multiply them directly, if I do a into b, if I multiply them directly and then take the modulo operator, 10 raised to power 10 into 10 raised to power 10 will give me 10 raised to power 20, which will go out of range. This is why this property is required, right? When I take modulo m, it will make it less than or equal to 10 raised to power 9, and it will make them less than or equal to 10 raised to power 9, and the product will be less than or equal to 10 raised to power 18, right? LL is long. LL is long. It is another data type in C++, like integer. Like I told that integer is up to 10 raised to power 2 into 10 raised to power 9. Long is up to something into like approximately 10 raised to power 18. I think 9 into 10 raised to power 18, maybe not. I don't remember exactly. All right. Cool. So now I'll just sort of show you how can we implement that. Great. So now, like we discussed, instead of we have this half answer, right? Now if we do half answer into half answer, we are storing it in int. Storing it in int won't be enough. We will have to have long. So what we can do is we can just return half answer into half answer percent m. All right, and before that what we can do is half answer percent equals to so this half answer will return me this this model. Just a second, let me just, yeah, this modular expo of a comma n by 2 will return me a raised to power n by 2 percent mod, right? So once I have this half answer, what I can do is just calculate, just multiply them both and take modulo with the mod value. Cool. And then else if n is odd, then again I have this long half answer, which will be this. Now if you see, I need to calculate this value, but since all three of these values can be up to 10 raised to power 9, I cannot multiply all three of them directly, because if I multiply all three of them directly, the result can go up to 10 raised to power 27, but 10 raised to power 27 cannot be stored in C++, so I'll have to multiply them one by one. So what I'll do is, first I'll say half answer equals to half answer into a into half answer percent mod. So now I have basically a raised to power n by 2 into a raised to power n by 2, and then what I'll do is half answer equals to half answer into a percent mod. So now I have a raised to power n by 2 into a raised to power n by 2 into a. So here I can just return the value of half answer. Cool. Now it will work correctly. So now here if I try to calculate, let's say 10 raised to power 10, it won't give me 10 raised to power 10. Sorry, it's modular expo. And it should be changed to fast expo. Yeah, it is giving me the modular value, it is not giving me the actual value now. All right, yeah, so this is how it is. Now I have a question for you guys, and again I expected to be able to cover GCD as well, but as you guys are experienced, I already know that we are out of time, so I'm sorry, I won't be able to discuss that as of now, because I just wanted to focus on the fact that whatever I am teaching should be at least clear. So that is why I try to take it slow, because many people were not able to understand it that fast. So yeah, that is why I'm sorry about that. GCD I won't be able to cover, but I have one question for you. Yeah, I can send the question. I can send the code. I'll just add its link to the chat. But before that, let me just ask you a simple question. I'll be reading the comment section for the answer. So the question is, given a comma n, all right, less than equal to 10 raised to power 9 and from 1, calculate last 5 digits of a raised to power n. Yeah, this is the question. So think of it, we have already sort of solved it. It is just a small thing that you need to think of. Anyone who can think of it can write it in the comment section. I'm reading the comment section of YouTube as well now. What we have to calculate, some product or what? A raised to power n. A raised to power n's. We need to calculate the last 5 digits of a raised to power n. So I can't see any answers on YouTube, which is fine. But yeah, many people have answered it correctly. All we have to do is just instead of calculating the real answer, just calculate this. Just calculate this modular exponentiation of a comma n, and after setting mod equal to 10 raised to power 5. So if you divide a number by 10 raised to power 5, and if you see what the remainder is, the remainder will be equal to the last 5 digits of that number, right? Yeah, so let's say we have a number x and I want last 5 digits. So for last 5 digits, what I need is x percent 10 raised to power 5, as simple as that. So this is what we'll have to do. Just replace the value of mod from 10 raised to power 9 plus 7 by 10 raised to power 5, as simple as that. Great. All right, so people were asking me to give you the code, so just give me a moment. I'll also add the code on Discord server, but I'm giving you the code right now via a paste bin link. Yeah, so I hope you are able to see the code. And regarding notes, all of the things that I've written on this slides, uh, they will be available after the class, so you can come to the same link on which we are having the class. You can download the PDF afterwards, right? So the notes, like the things that I've written, will be available after the class. I think it will take an hour or so to get for them to be loaded, but yeah. Okay, for GCD, since we have not been able to discuss that, and as said that we'll be discussing, just give me a moment. I'll just give you the link to the article where you can go and read how to calculate it. It is very nice, and you can refer to this article to calculate wherein you can see how to calculate GCD. All right, so after that you can also try these two problems related to GCD, which are nice to try. So I'm just give me a second. So this is the problem number 1, and this is the problem number 2. So you can also try these after having studied the GCD. I'm sorry, I hope you understand. I wanted to cover that as well, but time did not allow it to happen. All right, guys, I hope you did learn something new in this session, and I hope it was enjoyable for you as well, as much as it was for me. And yeah, I hope to see you guys in the other sessions as well. And actually, me and Surya are having another ask me anything session in just 5 minutes. So you can join that if you want to. The topic is going to be like importance of CP for getting into FANG companies. All right. So yeah, hope to see you there as well, and hope you are enjoying the lectures, and hope to see you tomorrow and day after tomorrow as well. Bye.